Alright, so this is part 2 of the differential calculus assignment, and I'm going to be handling questions 10 through 13 in this video, so yeah, I'll just get started with question 10. So this is a really straightforward question. They're not actually, you don't have to do any real mathematics. It's just a cubic that looks like that, and you have to draw the gradient function on the same set of axes. So I'll switch to red for doing this. So basically, the only information we have is that this here and here, the gradient is 0, which means the axis intercepts will be here. And between these 2 points, the gradient's negative, which means it'll be in this portion of this lower half. So with that being said, we can draw the parabola. That'll look like that. And that's the whole answer, really, because there's no numbers to work with. All the intercepts look really not perfect, so that's really all we can do. So we get down to question 11, which is a lot more fun. There's a lot more actual calculations to do. So question 11. So the function y equals ax squared plus bx minus 2. And here's the information we're given. The derivative equals minus 7 at 2 comma minus 4. And you might be wondering, like, there's 2 variables, but only one bit of information. But there are actually 2 bits of information here, and one of them is that when x equals 2, the gradient is minus 7. But the other bit of information is that it actually passes through this point, 2 comma minus 4. So with that being said, we can start working on setting up 2 simultaneous equations. So first, I have to actually take the derivative, which will be 2 times a, so 2ax, and that plus b. And what we can say is that the derivative evaluated at 2 is equal to 2 times a times 2, which is 4a, plus b equals minus 7. So that's going to be our first one. That's going to be our first. And then the next thing we're going to do is sub in 2 comma minus 4 into the original equation up here. And we're going to have minus 4 equals a times 2 squared plus b 2 minus 2. So we're going to put this minus 2 onto the other side and get minus 2 equals 2 squared is 4, so 4a b times 2 plus 2b, and we'll divide both sides by 2, and we'll get minus 1 equals 2a plus b. That'll be the second equation. So let's just set these up over here, and we'll get 4a plus b equals minus 7. We get 2a plus b equals minus 1. We've got equation number 1 and equation number 2. And we're going to subtract, because you can see we can cancel out these b's. So 4a minus 2a is 2a. These b's cancel each other out. And minus 7 minus minus 1, which is minus 7 plus 1, which is minus 6. So a equals minus 3. And then what we do is we just sub it back into one of these equations. It doesn't really matter which one you do, but I think number 2 looks a bit easier, just because there's fewer things. So we'll do 2 times minus 3, which is minus 6 plus b, equals minus 1. Put the minus 6 over here and make it a plus 6 on the other side. And make it b equals minus 1 plus 6, which is 5. So a equals minus 3 and b equals 5. Therefore, y, the end equation is y equals minus 3x squared plus 5x minus 2. And there is your answer to question 11. We've got a equals 3, b equals 5. And that's the ultimate equation once you get to the end. Alright, so let's go on to question number 12. So question 12, we've got this equation, p equals 20 root t plus 95. That's not really relevant to the mathematics, but the population, p is the population of mice, and t is the number of weeks. So we'll start with a. So it looks really obvious, and it's 95. But if you really want to show you're working out, make t equals 0, because after 0 weeks, you get population equals 20 root 0 plus 95. P equals 0 plus 95. P equals 25. So that's a pretty simple one, but I'm sure it'll get harder. So in B, so we've got the population after 4 weeks. So that means t equals 4, because t is the time in weeks, and we've got 20 times root 4 plus 95. P equals 20 times root 4 is 2 plus 95. P equals 40 plus 95, 135. And that's the answer to the population of mice after 4 weeks. So yeah, so far no calculus, just algebra really. Alright, so this one will need calculus. So we've got the instantaneous rate of change at 4 weeks. And so we can take the derivative, we're going to have to rewrite this equation as 20t to the power of a half. I mentioned this in the last video, so you rewrite that so you can take the derivative plus 95. And from here we can take the derivative. Half times 20 is 10. T, a half minus 1 is minus 1 or 2, which is rewritten to 10 on root t. So we've got that, and now after 4 weeks, so we set t to 4. So we evaluate the derivative at 4 equals 10 on root 4. Therefore, there you go, that's the answer to 12C. So let's go on to 12D. Okay, so after how many weeks will the instantaneous rate of change be? So, will. So really what they're asking is when will the instantaneous rate of change of the mice population be 2 mice per week? And so what that means is we make the derivative equal to 0. And as we know, the derivative equals 10 on root t. That's equal to 2. So the first thing we have to do is work out what 10 divided by, so 10 divided by what equals 2. So it's pretty obvious, but we'll just do the working out over here. 10 divided by x equals 2. Multiply both sides by x. X equals 5. So 10 divided by 5 equals 2, which you already know. But we have to work out what the number is that when you square root it gives 5. And that's also pretty easy to work out. It's just 5 times 5, which is 25. And we can verify that by doing the derivative evaluated at 25. Root 25 equals 10 divided by 5. That equals 2. So yeah, that is correct right then. We're correct right there. So we'll just write a worded answer. Therefore, after 25, no, that's going to go off. Weeks, the and that is the worded answer to question 12C. Alright, so what's up next? Question 13. Alright, this is a long one, but it's the last one in the whole assignment, so let's go. What question? Where's my pen gone? Okay. 13. So A. Actually, we'll write the question out. So we have a. So we've got a cylinder. That looks really bad. I'll just write can. Okay, can with volume 500 centimeters squared. Cubed. Centimeters cubed. So that's the information we've got. And question A says, prove that the height equals 500 divided by pi r squared. So this one's pretty simple because we know that the 500 is the volume and the formula for the volume is pi r squared, which is, imagine this is a cylinder. We've got h here. The area of this is pi r squared, and multiplied by h gives you the volume of the can. So we've got 500 equals pi r squared h, and then from there we just divide both sides by pi r squared to give 500 divided by pi r squared equals h. And yeah, that's pretty obvious, but just make sure you make it really clear that you're dividing both sides by pi r squared. So B. B is also pretty similar. It's another prove one. Prove that surface area equals 2 pi squared plus on radius. So here's how we can visualize the surface area. So I'll have two of these, which are on each end of the can, and as I said before, the area of each one is pi r squared. So and 2 times pi r squared is 2 pi r squared. So that's where that comes from. And the other thing is the T1 times, and this is the rectangle that goes around it with a height of h, and that is equal to 2 pi rh. And where this comes from is that the surface area of that is equal to the diameter, sorry, the circumference of this, and the way to solve for the circumference is 2 pi r, and then multiplied by h will give the surface area of that. So that's where this little thing comes from. But we know from the first question that h equals 500 divided by pi r squared. So we just sub that in here. Equals 2 pi r times 500 divided by pi r squared. And so what we have to do is multiply these together, and if you want to make it a little bit easier to visualize, you can imagine that that's over 1 and just multiply as you would any fraction. And 2 times 500 is the 1000 pi r, and then divided by 1 times pi r squared, so just pi r squared. And what you do is you cancel the pi's out, and you cancel this pi squared with this radius squared with the other radius. You get 1000 over radius. Therefore, 2 pi. And that is the proof for this question B. Alright, so question C. This one is pretty hard, and I did actually get a bit of help with this one. But once you have it explained, it's actually quite simple. So we're trying to find the radius and the height. So in order to use the least amount of aluminium. So to do that, so that means minimizing surface area. And as we just proved, the surface area is equal to 2 pi r squared plus 1000 divided by pi. But we have to take the derivative of that. So I'll just write that out again. Sorry, 1000 divided by radius. I don't know why I keep saying pi. But so we'll rewrite that as 2 pi r squared plus 1000 to the power of minus 1. Sorry, 1000 r to the power of minus 1, which we can then take the derivative of. So the 2 times 2 is 4 pi r, and minus 1 times plus 1000 is minus 1000 r to the power of minus 2, which is equal to 4 pi r minus 1000 divided by r squared. And the last thing we're going to rewrite it as is multiply this r squared out here. So 4 pi r cubed minus 1000. And because we're finding a minimum, that's a stationary point, which means that, imagine if we get a curve, that's not what the graph looks like, but we're trying to solve the minimum value, which will be here, and that's when the gradient will be equal to 0. So what we're going to do is make that equal to 0, and then we're going to put the 1000 onto the other side by doing 4 pi r cubed equals 1000. Divide both sides by 4 is the next step, and that will give pi r cubed equals 250. Divide both sides by pi will give r cubed equals 250 divided by pi, which will give r equals, and we want the cube root of this, which is equal to that to the power of 1 on 3, which means r equals that, and just type that in your calculator, and you will get 250 divided by pi to the power of 1 on 3, and you will get r equals 4.3 centimeters. Okay, so now that we know that that works, we just have to solve the height. And as I keep repeating, height equals 500 divided by pi r squared, which means height equals 500 divided by pi times 4.3 squared. However, when you do this calculation, I recommend not using just 4.3 squared. Use the full long one, because you don't want to make any rounding errors, just only round it off at the end. So I'm going to start by doing pi times that squared, which will equal 500 divided by 58.1, and 500 divided by the unrounded one of that, and then rounded off, is equal to 8.6 centimeters. So this is all the working out for part C, but I'm just going to write the worded answer to actually answer the question. Therefore, it's more like is 4.3 centimeters and optimal height is 8.6 centimeters. Okay, so that's actually addressing the question in a worded format. So, yeah, that's the end of question 13C and the end of the whole assignment. So I've answered all the questions in the assignment now. So, yeah, thanks for watching, and I'll see you in the next video, which will probably be back to just learning calculus, because I had to make these videos now, but yeah, I'll go back to basics of calculus. Anyway, thanks for watching. See ya.